In section 7.5, we're going to examine the area between two curves. So far, we've looked at the area between a curve and the y-axis. So the height, for example, on this right-hand edge of this shape is just f of b, because here's your function, right? And the height is going to be the y value at b, and that's what f of b means. And the same thing would be true for all heights along this curve. You'd have to evaluate it at any of those x values, whatever they happen to be. However, if you have two curves, and in this case, I've called them g of x and f of x. So g of x is here, and then f of x is this line. And I want to know the area between the two curves, between boundaries A and B, then the height of the curve, the height of the distance between those two is going to be f of b minus g of b. So in other words, here's b on the right-hand side. All right, so here I'm looking at this, what's happening right here at b. Well, this upper is on the F curve, and say, for example, that's 40. And this lower is on the G curve, and let's say that's 10. So it would be 40 minus 10, or it would be 30 if these were, in fact, our y values at B. So you have to subtract the upper curve minus the lower curve when it's between two curves. So let's take a look at example number 1. Find the area of the region bounded by the graphs of the given equations. And while this one's not that hard to graph, I'll give you the Desmos picture since you won't have access to Desmos on your test or final. Y equals x is a line. Okay. And those are points like, and I'm doing y equals x, 0, 0, 1, 1, 2, 2. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So there's that one. And then x squared is a parabola. So let's see, 0, 0, 1, 1, 2, 4. So 0, 0, 1, 1, 2, 4. And so this looks like this. Okay. And if I could blow that up, it's a parabola. The only thing they want us to find is this area in here. Right? So that goes from 0 to 1. That's the only area that's in between these two curves. So we're going to do the integral from 0 to 1. And remember, just like over here, we have to take the top function minus the bottom function. So our top function is the line, and our bottom function is the curve. And anytime you do integration, of course, you need that differential. So I'll take the integral. That's x squared over 2 minus x cubed over 3. I don't need plus c because I have the endpoints. I have to evaluate that at 0 and 1. So I have to do 1 squared over 2 minus 1 cubed over 3. That's 1/2 minus 1/3. So that's 3/6 minus 2/6, which is 1/6 minus 0 squared over 2 minus 0 cubed over 3, which is 0. So my answer is 1/6. So the area between the curves is 1/6.